Hello, fellow Mythrunians. Welcome back, or if you're new to the live stream, welcome. This is the weekly live stream where I do some development and while you guys watch, and hopefully it's entertaining. This week we're going to be working on like a shader that makes like screenshots that look like they're hand drawn. We'll go ahead and kind of get started. Let the patrons cycle up. In the upper left corner of the screen is the link where you can download the most recent release, which I think was from November, early November. I was trying to get one out this week, but I wanted to have the portals stuff working in there, and I haven't finished the portals. But I may put one out anyway because last time I talked about all the database stuff I was working on, and I did get that working, and it's a lot faster. So I get nice smooth movement over all kinds of zones, and it's quite nice, like nice enough that I really want to get it out to people. So if I'm not done with the portals soon, I'll just make a release. But I'm also kind of entering into my vacation time, which is going to be a Mythruna development vacation, when I'm not spending time with family. Alright, so the effect we're trying to go for is this guy right here, which was just a screenshot taken with the effect in the old engine. You can see the Mythruna girl has a ponytail in that because the original model had a ponytail. So I'm basically trying to port this to the new engine, which has farther terrain, farther horizons, farther terrain. And so that's what we'll be working on tonight. Hopefully that is entertaining to everyone. Hopefully my audio is working tonight. Alright, so let's bring this up. So what I did was I made a let's go ahead and load this up because we can look at the cool portals again, because I always like looking at them. Oh, and I started adding the effect that when the player stands on that center portal, the gateway activation pad or whatever, they're activated and they can go through the portals. And so I started adding that effect. I spent most of the week working on that database stuff, and I did get it working earlier in the week, so that was good. But then that took all of my portal development time. But in order to work on the hand-drawn shader, I didn't want to have to start the game all the time. And so I wrote a little script command that dumps the current scene to a J3O file, which is JMonkey Engine's save format. And I tailored that so I could load it into our scripting tool that we've been using for the last few weeks to do shader tricks. So let me go third person, and I'll show you when we step on to the pad, we get this like effect on us. It's basically just the pad, but I can replace it with any effect I want. But so now Fade's got that glowy, sparkly thing, which means she could jump through a portal, which just aren't activated at the moment. So that's that. Let me turn the lights on. So so what I did earlier was I came in here, and from like up here somewhere, I captured this scene. I dumped it to disk and captured the bloom settings, and that's kind of what we'll play with in the scripting tool. And this will give us a nice base to have a reloadable shader, and so on. YouTube keeps complaining. So here is in that scripting tool, here's the same scene loaded with the bloom settings and so on and so forth, so that we can play with the hand-drawn shader. And I can save any scene I want. So when we get something we like here, I can go back over and I can find a good tree biome and save that and see if we get good results, or a town. some various things, but I kind of wanted this because it's nice and lots of blank stuff, and we'll be able to see what's going on. This will also be a cool way when I decide I want to go and fix the the jaggedness of these far terrain texture tiles. This will be a nice tool for prototyping that as well. So I'm happy I implemented that scene dump thing. It's quite useful. I wasn't able to load objects because there's a specific class I'd need to port to something more general, but this works just fine. Okay. So I spent some time doing some of the groundwork when when we did the portal blindness filter. We had to implement this filter class and wire up some materials and things like that. And so I've copied that over from the original way back in the day. And you wired it up with our new noise texture and some stuff. I picked up our sketch textures from the old, which look like where did I check those out? Oh well, yeah. So let's so essentially this is the dark sketch. You can kind of see it's really dark, and then there's the lighter sketch, which basically I blend these in with some noise, and they look like the there's a couple different tricks that come into play for how this works to make it look hand-drawn, and we'll get to relearn those together because I don't remember exactly how I wrote the shader. I kind of have, like, in theory, the principle, but alright, I think the other thing I haven't done yet is copy over the shaders themselves, because I wanted to talk about what we're doing here. So let's go over to so we want here, and in the material defs, now I don't remember what it was called. Well, hand capital drawn .j3md. Alright. So mat defs. Hand drawn. I just want to keep the name the same. Okay, so when we wire up a shader, you create this material definition, which sort of defines the parameters you've got. This is like one of the simplest shaders you can have, and you can give it the name that you want it. To be a filter, a post-processing filter, you have to know what your number of samples are, which is sort of when you have anti-aliasing enabled. It means each pixel is actually multiple samples, and in order to properly do some operations, you'll need that information. But for us, we're going to have, I think texture is the color of the screen. So when you have a full screen thing like this, the engine sets the the whole frame buffer has a sort of color texture, and that's what's set into texture, and it has a depth texture, and that's what's set into depth texture. We used depth texture last week to blend in the portal blindness effect with the scene, and we're going to use this for edge detection in this case. And then we're going to want a noise, which is our sort of randomness that we want in, and we got a background, which is going to be the paper color, and then the two sketch textures, which will blend together in different ways. And this is the standard for every vertex, or for every post-processing shader. You typically just use the standard vertex shader, which essentially makes a quad over the whole screen. And then we have our hand-drawn frag, which I haven't created yet. Hand-drawn frag, which we'll work out in a second. So world parameters, we need time because I use time to index in to make it random, so each frame looks a little different, though it's really unnerving when you see it. It's fine when you're taking a single screenshot, but when it's like animated, it's really unnerving. So I may change how that works. Yeah, and these are things that typical wiring for post-processing shader. So let's talk about the hand-drawn frag. First, we will just... This is like all... See, this is the way I write shaders because I end up commenting stuff out. You've seen it before in previous stuff. Oh well. You didn't miss much. We're just getting into actually writing the shader. Okay, so first what we'll do, I'm just going to set up a basic make everything red shader because that's a good start. And I'm going to copy because I don't want to get it wrong. Yeah, so geofrag color. So make sure our wiring is right. Geofrag color equals color, or not color, vec for 1 0. So the whole thing will be one big giant thing. Oh yeah, that's the other thing. Okay, so we added the bloom. Yeah, okay, so we'll be able to do this. I'm going to cut and paste this stuff into our script so that we can, instead of the blindness filter, it will be the hand-drawn filter. I feel like I needed to pull my hair back into a ponytail again. I don't know if all of you know, but I have really long hair, and it's long in the front too. Sometimes that sneaks out of the rubber band. Hand drawn. Replace, 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 replace. So if I've done my job right, when I hit save, the whole screen should go red. Nope. Oh boy. Okay. So when I ported the Java code, I did something wrong. I changed something, and I felt like it was probably okay. No, it actually is a script problem. That all looks right to me, and none of it matches what the error we got over here. So there's a yeah, I've had this since high school, and since I'm old enough to have kids that have graduated from high school, yeah, it's been growing a long time. Way back in the day, before they were called mullets, it used to be short in the front, but some decade ago I grew that out. Although the picture on my badge at work is so old that I still have bangs in there, feathered off to the side. If you know what you're looking for. Okay, so let's actually look at the exception because no pointer cannot invoke set texture filter post processor render filter chain. What did I do wrong? Maybe it is in the Java code. Something is not correct. Ever do wizard? No, I grew a beard out a long time ago. Just scruffy. I have like cowlicks on my face, so some of my hair grows in a spiral over here. I always thought I kind of looked like old pictures of Paul McCartney when he grew a scruffy beard. But I just didn't like it. It was itchy all the time, and my dad told me it eventually stopped being itchy, but I just... And nowadays, when I let my beard grow out just a week and a half or so, it's like got all this gray in it, and I feel like shaving it, I like lose 10 years. I get 10 years younger just shaving my beard off, so I never let it get too long. You guys may have noticed to get kind of long on these before, but never more than 2 weeks. Because it starts to get itchy and I can't stand it. Plus, my wife likes me clean shaven. And sometimes that's what it's all about. So we've got asset not found. So I think that what happened is oh yeah, I had different okay, so I had different name. I had them in different places. So what happened was in this case the shader failed to load, and so like these are not in the right place anymore. This is just regular mat defs. Let's see if that fixes it. Put it into the game. Keep it up. You're doing an amazing job. Oh, thank you, Galactic Taco. It's nice to know people are pulling for me. I have been at it for quite a while. Filter hand drawn. Somebody's still loading filter hand drawn.j3md. I was pretty sure. There it is. I thought I had looked. Okay. We're getting closer. But yeah, I'm not exactly sure what I'm going to work on over this next 2 weeks, but I got like 2 weeks off from work. And so part of me, I want to get to the point where I can start posting the link in something more than just the upper left of the screen, like some, yeah, okay, so our shader's working correctly now. In order to do that, I've got a bunch of stuff to fix from server admin perspective so that I'm not sort of deluged with constant grief fixes and things. Yeah, just normal being able to back up parts of the world, revert parts of the world, and so on. So I kind of want to get to that point by the new year where I could start letting letting randos in. But I also kind of, I don't know if you creative people have the same thing, but you know, when you're interested in something, you're going to work harder on it. So part of me wants to just let my head go where it wants to go and get like twice as many cool things done, even if they weren't necessarily on my 2-week roadmap. Because one of the things that happened to me when I still haven't finished the inventory UI refactoring, because you know it's like now I got to get into it and relearn it, and so I drag my feet working on it, and I feel like I need to work on things that are just interesting and that I'll perseverate over for 18 hours a day and just get lots of stuff done. And sometimes when I'm doing that, then the other stuff is easier to work in because I'm already in a mood and on a roll. I'm also still kind of healing from my back problems last week. Anyway, so we've got a red thing. Now we can start filling in the stuff. And how do we want to do this first? So that's where our red color is, and I can prove it by changing that to yellow. And so then if I reset this, it should turn yellow. Yep, there it goes. Alright, so in the old hand-drawn shader, we had, I don't remember what I used this pound to find for. Pound of def. Okay, so that's mixing in. I do want to parameterize a lot more because I felt like there were, for the other thing is when I'm going to use the hand-drawn shader when the player has the ability to draw pictures in the game. I would like the hand-drawn shader to be there as a tool they could use to kind of just scrape their mouse over the picture to kind of get a sketch down that they could then paint in or draw over as they want. So this would be kind of like one of the layers. And so I do want to parameterize a lot of stuff is where I'm going with that. Okay, so we could have actually gotten the near far from JMonkey engine, but I don't think I even did. I think I didn't even do that with the other. Okay, so let's depth to Z here, and that's going to be a lot bigger number. Actually, I think I set it in the hand-drawn shader to 9,000. So let's pull this in. I think for now we'll always include shading when we get to that point. These are all the parameters we wired up in that material, and then the texture coordinate is what basically our position on screen. And for this I'm gonna bump it up to 9,000. And so now we've got that depth to Z thing we had before. And what was the other? Yeah, so this actually would give us that gives us for a depth texture, we can get the depth out of it. I don't know if that's a great name for it. Made sense when I wrote this, 10, 11 years ago. And so then in here, we'll get the screen color. We have the background on a certain repeat. We have what we would have been in the sketch. Yes, so we get all of these. Why am I getting sketch twice? Oh, because that's going to be the pencil line. We'll worry about that later. What we do want is the texture value and Z. We're going to prove that we have Z. So it's just, these are our screen stuff. Get the frame buffer stuff. I'm going to try to comment as I go, both for my own understanding and everyone else's. Okay, so we ought to be able to then do like we did last week, which was sort of use this Z value. Let's take it Z value over m near far dot y. So that's the far. And so we do this, it ought to paint depth, like black and white depth, unless I've screwed something up. Nope, we get depth. I don't know why. Oh yeah, I did it as red, not. If I had done this, if we do this, and then set GL frag color A equals 1.0, and then reload, everything should be white. Yeah. Okay, so yeah, so there we've got, we see our depth as it goes off into infinity. And from here what we do is we'll use the depth to extract edges. Now I've currently only got 256 values of depth essentially, so you can't really see that there is fine depth differences here. But what we'll do is we'll use kind of nearby samples to do edge detection. And that, I believe, is, I don't actually do many samples as I figure out here. Where do I do more extract Z? Oh, it's in the edge level. Okay, so here is, well, maybe I'm not using the depth. Oh, that makes sense because you want it to be based on the picture, not the depth. The depth could give you a clue, but for any of the flat surfaces, it wouldn't find the details on the flat surfaces. So we have this edge level, which does a Oh, thanks. Thanks, Max. Sorry you can't hang around, but you will be missed. It's interesting that I think this X scale and Y scale is probably incorrect. Because that looks like it's based on a smaller screen. But that's okay. Actually, I think it works out all right. No, we're going to need to know the actual screen size. So just in case, I'm going to put these at what my normal screen size is. So what this is doing is it's kind of doing a convolution filter over a 3x3 area and doing what's called a Sobel filter. Yeah, these names don't mean anything to me anymore, but I used to do a lot of image processing playing around, and so those made sense to me back then. I don't remember what Frey-Chen is and why it's different than Sobel, but at any rate, we get figure out a horizontal edge and a vertical edge based on these convolution filters, which if you don't know what a convolution filter is, maybe that's a topic on its own sometime. And then so uses this formula to figure out whether we're at the edge of a thing or not. So I ought to be able to, I think it should be 0 to 1. So let me just pick the same. Do I grab the edge level just once or twice or 3 times? Roughest. Oh, I grab it a couple times. Why? Why would I sample the same texture twice? Oh, I'm not. It's oh yeah, okay. So we do some randomization in our sampling based on the noise. So for the moment, I'm just going to use a different name. So we'll call this edge. Ooh, edge level. It wants the color texture. It wants a scale, which, what was scale? Oh, just 1.0. Okay. 1.0 and a text chord. And so instead of RZ, I'm just going to dirty up my shader again here. So we'll sit at the edge and see what that data looks like. Whoa, alright. It doesn't like something. On line 132. Oh, interesting. Square. Implicit narrowing of type vec3 to float. No. Oh, I guess because... How did that work before then? Are those supposed to be... Good times. Let's look up Sobel edge detection. I usually like back in the day, Wikipedia had like approachable articles. Now I find I drop in and it's all mathy things. Okay, so we've got our edge detection, so we'll end up getting vectors out of there. And then what do we do with those? We take the square root the x-coordinate finds here is increasing to the right direction, the y-coordinate. So this is essentially taking that color, but we kind of want the brightness of the color, I guess. And so I'm wondering if I want to well, for the moment, let's see what we get out of here. I don't know if GLSL square root will work on multiple values. Gen date, gen type, it will. So presumably I can pass a vector. So pass a vector, return that. Let's see, vec3. Alright, let's see if that will run. It may look weird. Cast not allowed. On 144. Oh. Yes, of course. Yes, of course. They won't work. We cannot do it, Captain. Alright, will it work? Will it work? Will it work? Oh yeah, there we go. Edges in 3 colors. So it's kind of cool looking. We get like lots of little edges right there because of all the sand texture. Alright, but we're detecting edges, and it seems like the brightness of the final color is pretty edgy. There we go. Alright. So we got edges. And I think that if let's change this for I believe I can do vec3 max edge. Will that work? Let us see if it's gonna crash. Yep. Alright, so apparently won't like reduce it. Yeah, so whatever type you pass in, that's the type you get out. Excuse me. Got the burps today. So edge X, edge Y, and then max of that, and edge Z. or RGB. So now we're basically turning that into a grayscale. I kind of wonder if it would be better I just wonder what the old shader was doing as far as compatibility. It might have just been returning red, because you know that if we just did red, we'll just get the one channel of, yeah. So probably what I want to do is convert those colors to black and white. And I have a shader that did that recently. What was I using HSV for? I have some shader functions I wrote that will convert color to black and white. I'm trying to remember what I used it for, because then I remember what shader it's in. What shaders did I write recently? Oh man, this is gonna bug the hell out of me. A history of everything I do is in GitHub. So perhaps I can get some insight there. So all of the commits. Post-processing note blindness, we didn't use it for that. At least I'm pretty sure. Oh, maybe world previews. No. Wouldn't have been drop shadows. I can't be sure I named the function. I just don't. I don't feel like rewriting an HSV converter if I've already got one, you know. So we're starting to get back into November. Yeah, sure. I'm not seeing anything jump out at me. Oh, I wonder. Oh, it might have been the. It could have been the materials for butterflies. Or was it something to do with emission shaders? So it's either HSL or HSV. Alright, let's just do a little grepping around. Oh, we're in the wrong direction. Okay. All right. Find source dash name star dot frag xargs grep. Is it dash I? I think it's dash I for case insensitive. HSV. HSL. All right. Let's go over here. Try here. What the hell was I doing? Okay, just in case it was really something over here. What the hell was I using it for? One more place we can check. Oh, well, I left the dot out. Oh boy. So these may not have been finding anything. Because you gotta have the dot, I think. Alright, client. Yeah, so I didn't name it anything that I'd recognize. Alright, well, maybe it was Java code. Or was it Groovy code? Let's try again, only with Groovy. Nope. All right. I don't know. I'm gonna have to relearn it because I don't want to spend too much time dumping around. But man, that's annoying. Let me just make one more pass and actually look at some of the shaders just to make sure. Was it local lighting? It was the ghost stuff. That's what it was. So where... Oh, ghost.glsl lib should be in here. Or maybe I put it somewhere more central. Let's try... here. Thanks for bearing with me, guys. There it is. Yes. And HSV. So I made a whole little library. That's how cool I am. I just have to remember that I did it. So if we import this, we don't even have to write anything. So let's go back to hand drawn. Let's import our HSV thingy. And then, where were we? Let's see, so RGB to HSV is the one we want. And yeah, cause so let's just see what this does. I'm going to show you kind of what it does. HSV with the screen color. Let's call this screen color. I think it will be clearer. Okay, so HSV equals screen color, GL frag color, RGB equals HSV. I'm going to do some stuff with it in a second. So let's see if that's what we think it is. No, I'm afraid I'm not. Oh yeah, okay. Sorry. My bad. Try again. Alright. Okay, so yeah, it's kind of funky looking, right? But so the red is our hue, green is our saturation, and blue is our like brightness, if you want to think of it that way. So if we do that, oops. If we do that, we should just get brightness, and so it should be a black and white picture. Yeah, so there we've got black and white and some very subtle. So like if we were here and trying to edge detect here, we'd get all kinds of detail, but everywhere else is just kind of smoothed out. And it's unfortunate this sky is not indicative of what the sky in Mythruna will look like, and so I don't want to spend too much time optimizing for that. But and also, like, I think it's at infinity as far as distance goes, and we will scale whatever effect we have by distance for sure. So what I want to do is, excuse me, I think I want to make all of these float, and then yeah, so let's turn all of those into, and we can still leave them all as, actually we can leave them all as so all these are going to need to be RGB on the end. And actually, let's just, yeah, so we can make all these, we don't care about the transparency. Hey, how's it going, Lando? Happy Friday to you as well, and this is the first day of my 2+ week vacation, so I'm especially happy today. Okay, so in this case, we don't care about anything but Z, basically. So that's going to be the brightness. And so if we go back to our edge level can be float again. Float, edge level, and so edge. We can comment out these. Now we should get, well, we'll see. It'll either bomb or it will give us edges. Yay, we get edges. See, we get edges in the sky, which is not great. But we can choose kind of what level we want edges. The other thing is that we are going to want the brightness of the color anyway. Okay, so for now we've kind of got all that working. I'm going to clean out a little bit of this garbage. So we're showing the edge level. The next thing to do would be to work on the shading. And so we're going to need our sketch layers. And what was Cmax for? Oh, it's the max of the color. Yeah, so I was taking the maximum of the screen color, which really should be the brightness. C length. I was playing with lots of things there. We're gonna forego randomness for the moment because I want to I want to see it sort of in its pure form. Don't know if that's educational or not, but we'll see. So these are sort of the base sketch layers. For example, if instead of this we set frag color RGB equal to sketch RGB, we're going to get like a really dark screen. Watch. Boink, see, it looks all black, but it's not really. It's kind of like, let me switch to the lighter sketch. You'll see what I mean. That's not right either. I'm wondering if I've got something wired up strangely. Don't scale the texture coordinate. How do you get better at the math behind the shaders? I guess it depends on where you start. I've been doing this a long time, and I'm not great at math. Boy, I'm really disappointed that my sketch is not coming out. But some of it's simple. Like especially in post-processing shaders, stretched over the screen is a sort of a quad, if you think of it this way. And down here you have a texture coordinate of 0, 0, and up here you have a texture coordinate of 1, 1, and so down here is 1, 0, and 0, 1 up here, and your frag shader is going to be called for every pixel, and you're going to get some fractional component of the texture coordinate. So if we like pumped the texture coordinate directly into like our RGB, or just our RG, we set this to textcore.rg. Actually, textcore is vec2 already. So if we did this, we should get like a gradient over the whole screen. Yeah, so down here, the texture coordinate is 0, 0. As we go up, the red goes up. As we go up, so kind of if you can, shaders are kind of neat. If you can avoid getting frustrated by the really specific syntax of the C-like language, or you can use Shader Toy and play around with things. But you start with something simple like that, and you go, well, okay, well, what if I then, you know, what happens if I multiply it by something, or I do this thing, or you know, smooth step it, or do other things, and you can kind of slowly build up a repertoire. Why is my... So let's multiply this by 0.2 so it's really stretched out. And so I'm trying to figure out why my sketch layer is all black. I bet it's the transparency. I bet, is the sketch layer all black with a transparent value? Let's try and see. No. So this makes me think that I copied the dark texture over both slots. Descriptor, drawn textures. Sketch, there's the dark one. No, see? Sketch light should be the lighter one. That is what we should have seen on the screen. I just wasn't sure if the white was... I suppose it could still be alpha. One way to check would be to open it in Photopea. Photopea. Where are we going? Where are we going? Not moss. But. Yeah, back when very earliest computer graphics, computer stuff I ever did was computer graphics. Like, I was 6 or 7 years old, and you got to realize video games were really not great back then. And I played my first video game, which was some simple little thing. And from that point on, I wanted to make video games. I was designing them on paper. I'm going to show my age here, but there was a show on TV called Chips, and I had designed a video game around, you know, riding motorcycles. So that was California Highway Patrol, for those of you who aren't old enough to even know what that is. But it was a police show about 2 motorcycle cops on California highways. And so I like designed on paper. I had no idea what coding was. Alright, what was I looking up here? I got lost in what I was doing. Oh, yeah, I was going to open the image. Okay, so model set. I got distracted with my own story. Textures. Sketchlight 2. Okay, so I think it's just black and white. Oh, it is. It is UV. Okay. Alright, I see what it's doing. I'm bagging what it's raking. Okay, so in that case, let's go ahead and run our thing again. I know how to fix this. So, and setting alpha, I think that basically we're drawing everything over the screen, and so we're not going to see alpha unless we mix the original color in there. Excuse me. So essentially these sketches, we could ignore the color completely, I think. And so we're just going to mix so RGB, we'll mix all black, oops, or all white with, this is going to be inverted, this is going to be fun. Sketch light.a, oops. So the alpha of that, and I think that works. Yeah. So yeah, so there's our really super close-up sketch. We can go back to the original recipe. Yep, so there's our sketchiness. And if we were to mix that with so I just wanted to verify that the texture was even there, and I'm kind of glad I did. So, what do I want to do next? Well, first of all, I could, if I just pump screen color in here, it should make it look like the image was drawn, or kind of scribbled onto, oopsie, frick. That's me forgetting type coercion. Alright. I was pumping an RGBA into where an RGB was requested. And the shader doesn't like that. Yeah, so see, it kind of looks like it's sketched onto, if you don't move, right, it kind of looks like color pencil sketched it on. That's more or less the effect we're going for, right? Okay, so now let's go back and look at the original shader and try to figure out what the hell it's doing. So level, we got the edge level in two different places. And we did a bunch of stuff. Oops. Yeah, so we did some noise stuff. Even up here we did some noise stuff. Oh, and we have a radial thing too. Oh yeah. I wish I had commented some of this stuff as I was going. Oh, I'll remember what it was. You never remember what it was. Trying to remember what I was doing. So essentially what we want to do is we want to do the edge detection, and then there's going to be, like, if we look at the original picture, we combine a bunch of effects together. We do edge detection, and we draw a light version of the edge with one noise value and a dark version of the edge with another noise value. And we draw that over sort of the lightness and the darkness that are used to figure out both which of the sketch textures are used and how much intensity to give them, so that you'll have like variations in really dark shadows and variations in lighter shadows. And so you combine all those things together and you get kind of this effect. And I think I could also have a slider that would bring a little color back in. And so I'm trying to remember, because this looks not too bad, right? As I kind of looks sketchy. Sketchy. So I'm trying to remember all of the different things. And so we have, oh, and the other thing is, so there was a radial effect as well. So towards the corners, you can see the the shaded part blurs a little bit. It kind of fades out, but the drawn part really fades out towards the corners. So, because the idea is if you were drawing this on a sketchbook, drawing towards the corners and towards the edges is really hard. So you're probably not going to do as much detail towards there. It's kind of going to fade out towards the edges because that's what a sketchbook would look like, right? Okay, so earlier on, okay, so this is where we're doing the shading. We take the sketch alpha, the darkness, which has a fractal component in it. So, yeah, so let's deconstruct the fractal. Here we're building, so this is a classic multifractal. I don't know. Let me see if I can illustrate what a classic multifractal is. So let's come down here. So we start out with 1. There's going to be this interesting time component. I may take time out of it for a second because it's going to be really wigged out. But let me just pump this into let's see if this is even going to work, and then see, everybody's defined. Noise, text core. Yep. Shouldn't crash. Oh, except for it did. 178. Oh, it didn't dump the shader for me. Export a float. Fractal offset, fractal offset. Oh, no. Implicit cast narrowing of, I mean, it's got to be down here. I wish it had told me. Ah, here we go. These are all supposed to be .r. Man, the old shader let me get away with some stuff. The old. Okay, so let's try again. I kind of went over. I think I kind of went over this. Yeah, so we get that time component. Let's take time out of it for a second. So it's not constantly moving. We can get a little bit better handle on what's happening, right? I kind of went over this before with the cloud shader. I don't know if it was clear, but the basic idea behind fractals in general is you get this self-similar behavior. So there's the multifractal, which if you started out with you know, a really low resolution sampling, so maybe you took, you know, this many samples and you got this, then you would sample again at a higher frequency. Usually half is a good number. You know, so you might get values like this. Where I'm kind of trying to simulate sampling at a higher frequency here. Okay, and then you would sort of add or multiply those together depending. Usually you could add this to this at a lower rate. So then what you might get would look like, let's see, this added to this would be, let's see, it would be kind of like that. And then, you know, if this is your median point, we would probably subtract this. And so this value actually comes out to be a little lower than this one. And this one also lower, so we would subtract again, and we get like here, this one's coming up a little higher but still lower, and so because this one's already lower, we go down, and so you end up with, you know, a more varied fractal than you originally started with, and you keep layering and layering and layering. And so it's easier to see in 2D than in 3D, and I don't really want to do the math to convert this into a line on the screen, although I guess it could. But anyway, if I was to take out the higher samples and show you just one layer, so you get this really sort of, that's the low resolution layer, right? We just get this, so we're going to add, what are the multipliers I'm using here? So the next layer is essentially 1/10 of this. So if we just use the next layer, for example, and the offset I don't really need, as it turns out. So this will be a higher resolution version, right? And then the final one is even, oh, I see, offset versus, is even higher resolution than that. Though, is it? No, that one we're just adding, that one's actually a lower resolution. Yeah, because here we were doing 1/100th. This is interesting. It's not 100% straightforward what I'm doing here. Okay, so here we've got, yeah, a medium resolution. I've just got them in a weird order. And so you combine all those together in various ways. So this lower one, oh, I left the lower one in, that's why. Put this back and go like this. Okay, well, anyway, you combine all those layers together and you get the lower resolution combined with the medium resolution and the high resolution, and it gives you this sort of bumpy varied fractal that is not very repetitive. You don't, although I can see that there's a bit of repetition. I guess it's different. Similar looking but different. At any rate, so that is what our fractal value is here. It's not a completely straightforward multifractal, but that's kind of the idea. And if we set this back to G time, it's going to change every frame, so that as a basis of a noise texture, some of it moves faster than the other you see, Like the low resolution stuff is not moving. I think it's not moving at all. Right, the lowest resolution is not moving at all. And then the slightly higher resolution, I guess it's actually not any higher. Yeah, this is interesting. They're all using the same texture coordinators, sampling different. Yeah, so they're just layering different slices of the same resolution texture apparently, but moving at different speeds through time so that we get a little bit varied. I actually don't like this, but I'm not going to change it right now, and I am going to put time back to 0 because I find it unnerving to have my sketches move around while we're looking at them. Okay, so we've got that noise, which is used for down here in the shading. Oh, and there was a C max. What was C max? C was max, the max is color. We can actually use brightness instead. So let's just remember that. Just has background or dark. Yeah, so I tried a bunch of different things originally. Okay, so let's see what we've got going here. So that was just showing the raw fractal. What we're doing here is, okay, so we want a float color level, and we are going to set that to the, alright, we'll real quickly do another black and white test so I can show you. Screen color, I think it's just RGB. Yeah. Dot Z, so that's going to be the brightness. And so if we do this, this should be a black and white version of our image, which means we'll be able to look around again. Yeah. So we've got a black and white version of our image. It's just based on the sort of the V of HFV. Alrighty, and so what this is doing is we're figuring out the darkness level, which is going to be this color level times our fractal. And to illustrate what that is, I will set the value to darkness and we'll see what that looks like. Yep, so it's inverted, right? So the darker the value, the brighter the color is here, and we're mixing in some of that noise, and so we get sort of a these are the things that are going to get drawn, if you want to think of it that way, like sketched, shaded. So that's the darkness. I need to get rid of all these extra ones. Okay, so that's the darkness. Then we take the alpha of our sketch, we square it so that it's got a different curve, we multiply that by the darkness, and then we multiply that by 1 or 0 depending on, oh no, sorry, yes, the darkness is greater than 0.6, so it's really, really dark. This will be 1, and if it's below 0.6, that'll be 0. So basically that's like a cutoff, and then we lower that darkness value. So if I come over here and I pump this into color, what we should see is only the darkest things get shaded when this refreshes. Yep, so see, these are the very darkest areas of our picture. And so then we take that value, find the very darkest areas image of the color image. We've got many images we're working from. And so then this is sketch light. This is taking everything. Oh, it's adding in a little bit of the light sketch layer. It's otherwise exactly the same, except we're adding in a little bit of the color. So let's see how this changes things. So yeah, it's just bright, little more sketchy, right? So it's, that other layer was really dark, but now we've got more pencil lines. Let me show you before and after. So this is before. You can see how they're just kind of dark blobs. And then after, some of it brightens up a little bit, and you can see the sketch lines a little better. And then this is inverted, so we're kind of doing it backwards. Maybe I could turn it back so you can see what I mean. So we'll do 1.0 minus for both of these. Okay, so I think cool. Okay, my younger child is home. Okay, so let's show kind of what I'm, instead of inverted, I think it'll be clearer. Yeah, so see, we've got sort of a wishy-washy blobby sketch that's not very dark, but this is supposed to be the darkest part of our sketch. And so we'll add back in some more pencil lines, and so it'll look more, you see, we got like areas that are more sketched in. So this is our dark shade. And then we add in the other side of it, which is anything that is below 0.6 is going to get 1, and we basically just multiply that by alpha. So then that'll fill in a lighter version for all of the other places that have any shading at all. And so this should be kind of like a black and white sketch, right, with no... I think that's a pretty cool effect right there, right? You've got no lines, but you have this sort of hand-sketched look to things. I think that in this particular scene, I think that our fractal is providing too much shading. Like, you want to kind of think of some of maybe got smeared when you were drawing it and stuff, but that's a little much. So we might want to, and again, some of this is going to be situational. Our particular image that we're using doesn't have a lot of material to work with in these areas. So it's going to be extra apparent that we're adding in sketch stuff, but I think we probably want to tone down the contribution from the fractal. Can I just clamp it lower? Or no, I think this is going to make it worse, because that fractal value is going to be even darker. Yeah. Although that's an interesting clamp, so that's interesting looking, but what we really want is it never to be smaller than a certain value, but eventually that'll be an interesting parameterization. So this will go the other way, yeah, and we kind of fade some of that out, right? That's really dark up there still, so let's change this to 0.5. I like shaders because, yeah, see, this is okay. I like shaders because it's kind of combining math and art in a way that's really fun. Yeah. So interesting. So it's kind of cool because it's, I don't think, I don't understand how I could just come up with this outright without, you know, iterating like this and tweaking it. Okay, so now we've got our shading, and interesting that they're multiplying by edge, which we still have, right? Yeah, so we should be able to this is mixing background with black. I don't want to use background for the moment because I kind of like the white for what we're doing here. So let's mix in just Vec3. Let's just mix in white, and I'm leaving all these redundant frag color set. Frag color is basically the output to this particular pixel on the screen, and I'm leaving them in there just because it's easier to comment out different sections. So we've got the color which we're building up, which is not really the color, and then times the edge. This should give us that dark edge back again, and so we'll get like a straight drawn so that is why, interesting, that might be why I had the other fractal value. So this gives us a little bit of a sketch to our lines. But it completely wiped out our darkness of the right. I kind of liked the shading here. I kind of want to mix them more directly, like instead of multiplying, maybe we want to add and just make sure it never goes above. I should have kept the originals down here anyway. So let's see what this looks like. Oh, there it is. Wow, that took a long time. Okay, so that's too much. I also think this. Anyway, I can't get too wrapped up in the sky because because this is not the Mythruna sky. This is the generic sim effects sky. So I think what I want to do is narrow we could do this in a different way. Instead of clamping, I mean, we want to clamp anyway. But instead of just taking the raw value, we can narrow it down to just like a small range. So what I want it to be from like 0.7 to 0.8 or so. And so if I 0.7 plus the existing sort of what should be 0 to 1 and multiply that by 0.2, so we get basically whatever 0 to 1 was before is now going to be 0.7 to 0.8. And let's see what that does to our shading. Boy, it's taking a lot longer for these to show up now, and I don't think that's I mean, it can't. Basically, the shader's having to recompile. Okay, I kind of actually like the shading now. That's okay. We get a little bit of variation here. Darkness in here, that's good. Then I think our edge is just a little too intense, maybe. So let's let it recompile. There we go. We're narrowing in on something. Taking a long time for our shaders to recompile, so I'm probably trashing my card. What are we doing here for frames per second? Oh yes, that's no. We're not overtaxing it that way. Yeah, so this is pretty close to where I was going. Like if we think about what the original image looked like, equals screen color. Right, if we think about what the original image looked like, it's got very dark areas, very light areas, and it's taken a really long time to recompile the shaders now. Yeah, so really dark areas, really light areas. So that's not bad. The desert is a really stark place because you get these really harsh lines. And so, in fact, we can take a screenshot before we change it back. And it's recompiling. Okay, and then we can take a screenshot. And then, not that one. Not that one. This one. so we can compare these two, right? So that's the color, full color, actual in-game version, and this is the sketch version. And it suffers from not having any sort of variation in the lines, which is what we can work on next. So let's do that, and I'm going to leave this up in the background so we have something to look at, and I'm going to exit out because our I'm thinking giving the shader a break for a second. Okay. So I wonder if it also doesn't, anyway. Okay. So the other thing, let me label what we've done so far. Detect edges using brightness. Sample a multifractal. It's not a multifractal though. Maybe it should be. I'll call it a layered fractal. At different offsets. Although right now we're not. I bet if I set this to 1.0 we get a different. To do multifractal. All right. Narrow fractal influence. From 0.7 to, I guess 0.9 is what it really is. And use the brightness level of the color to sample the shading textures. Okay, that's more or less what we're doing. And then the other thing, so shaders work kind of backwards as it's sampling. So when you are drawing this pixel that's near this mountain, you are drawing that pixel no matter what. And so if you wanted this line to be somewhere else, you have to think about it backwards. You don't want to draw this line over here. You want this pixel to sample over here, right? It's a backwards way of thinking about it, and it becomes second nature after a while. But you'll see, I think what I'm going to do is I'm just going to pump in our texture coordinate into some noise, and you'll see that it'll roughen up this value. And I may leave the original one in place. Since we've got this edge, edge draws an edge. And we want to change where we're sampling for that edge to make a rough edge. And I think maybe I'll make two edges so you can see the original versus the rough one. Okay. So we've got the original edge, which is based on the straight texture coordinate. And let's move these back up here. Actually, where do the first place we use them? We don't use them down here, so yeah, we'll use these. We will keep that stuff together because I may break these out into separate functions later. So this is the straight, no randomization edge, and we want to sample a different edge, an edge in a different place of the image rather, based on sample our noise texture fractals. So I'm gonna figure out what I was doing before. What was I using C-length for before? Nothing. Okay. Okay, so the first UV offset we get and we sample roughest. Okay, so let me copy this over. I'll deconstruct it as I copy it over. So we have this UV offset. We sample our noise texture at like half. So basically, it, just on this alone, it would repeat our texture once over because it's sampling at half. No, it's the other way around. We're gonna we'd end up stretching that texture such that if we're just drawing straight, actually, why talk about it when I can show you? Oh, was I already using a multi-texture? That's interesting. No, I think not. That was a black and white texture. So this is going to be better now than it was. So let's, here, I'll just comment out all of this. Commenting bad. Pound if def not defined. So we'll just wrap that for a second. And we will, I just want to show you what that UV offset looks like. So RG equals UV offset, GL frag color B equals 0.0, and A, oops, equals 1.0. So I'm just going to show you what I'm talking about when I'm talking about sampling that particular noise texture. Hopefully this is instructional. I don't know. Maybe in another 10 years when I go back to look at this, did I start something in the wrong place? All right. Let's do the old-fashioned way. Comment it out. Astrobot game on PS5 tonight. I'm not a big fan of platformers, but it's really well done. Neat. Nice. It's all I can do not to be playing Baldur's Gate 3. I almost dove in back again. Like, oh no. Mythruna is my game right now. Okay, so here is the noise texture when I multiply. Well, okay, so let's just change this back to text chord, and you'll see what I mean. This texture will shrink. Right, so when we were sampling it at 0.5, we were seeing this, just this section stretched over the whole screen. So yeah, so pay attention. This section right here, this quarter of the screen, basically that texture gets stretched over the whole thing. Right, so we kind of zoomed in on that section. So we're a lower resolution over the whole of the screen. And then what the original code did was also add in, I'm going to move my time value up to here. So it also added a time offset just so every frame would be a little different. and a little different in both X and Y. But other than that, it's just moving the coordinates slightly. So this will just shift a bit. If I refresh, it's just going to move it a little bit. Oh, it's moving it constantly. Oh, I left the G time here. Yeah, so you can see it's just shifting through that texture because you don't want it to be the same every time. And I don't want it to shift while we're sitting here, so we'll just pick a fixed offset for now. All right, so the red and the green are our X and Y offsets that we'll use to sample into the texture to determine the edge. I'll kind of show you what I mean in a minute. So that took the UV offset. Then we turn the UV offset into, so the UV offset is going to be 0 to 1 in both directions, and so we want it to be -1 to 1. So we multiply it by 2, which makes that 0 to 1 be 0 to 2, and then we subtract 1, which makes it -1 to +1. And then it's interesting why I bothered to invert that. So then we take that, we add that to our original texture coordinate, this UV offset, but we narrow it down to be like 1/100th of what it was. And so now we've got a completely different UV. We change over here. These will be like really localized, I think. Well, because if I try to visualize this, it's not going to make much sense because it's just going to be one big red-green value from the regular UV offset. So primarily, we're going to get that with some small variations. Maybe too small, I don't know. And so from that, we get our roughest value, which is going to be the edge level of the texture at that coordinate. And so if we were to then, yeah, I should have left these up here. In case we want to play with that again. And then let's pump roughest into our output. RGB equals vec3 roughest. So this is the roughest edge. It's the edge with the most deflection. That's what my code says anyway. I don't believe it because this is a really small offset, but we're going to see. So that should be an edge. Yeah, okay. So that's an edge, but it's apparently supposed to be rougher than the original edge. What I will do is I will render the original edge as green and this edge as red. So green, actually we'll make the original be purple, not purple, cyan, and the roughest that I just sampled will be red. So we'll be able to compare the two together. Right, so we've just offset it basically. It's got almost no variation. I don't know how that worked out. I could have these backwards. Maybe roughest wasn't really the roughest. Oh, we've got rough and rough 2. Boy, that this looks like one of those 3D images where you wear the red-green glasses. um, so yeah, what are we doing here? What are we using level for? So I discovered this by accident. I was already clamping, I was already moving that fractal um, earlier, going back to what I did down here with the fractal, and I kind of discovered very, very close to the same values. This is doing basically the same thing, only it's making it 0.8 to 1.0 instead. So we'll leave that. We'll come back to that later. Anyway, just happened to notice it. So up here, let's take these others over and see what they look like on their own. Okay, so we get a new UV offset. This one, instead of being, yeah, so this is like the roughest. It's the least rough. It's kind of weird. It's the lowest resolution. So here we were stretching that little portion of the fractal over the whole screen. Here we're having the fractal repeat 10 times over the screen, so it'll be really high resolution. And I'm going to change these to time. RG, good, all good. And we move it to -1 at the bottom. This time we make it really teeny small offset. And so, excuse me, so this is the next level of roughness. And then this is sort of half the resolution of that. So let's change this to time so it's not sliding around on us. And we move it to 0 to 1. We multiply that by also really small values. So we end up with roughest, rough, and so we want roughest to be red, rough to be green, and rough 2 to be blue, and we'll see what that looks like. Doink, doink. Right, so we've got sketchy lines compared to our original nice smooth lines, right? We've got these various levels of rough line that's starting. If they were all the same color, you know, they would look more like a sketch instead of a bad TV. And so that's when we take these levels and we start doing something with them. So let's now do something. I can get rid of this. Let's now do something with them, which is combine them in a way. So where did I define level? Okay, well, we're completely wiping out level here, so that's good. And we're only using roughest and rough. I don't think we ever use rough 2. Maybe we should be. Nope. So we only combine so if we only use rough, let's just see what the original edge would have been. I think we're going to be just, the whole thing's going to be offset, and I think that's something we want to pay attention to. No, it's not too bad. So the blue is the original regular actual edge of the image, and then the red, you know, is the lowest offset version, and the green is the higher offset version. I think probably we do want to include rough 2 in there, but we have options. So then level, normally we can see just what this would look like. Which is sort of the, you know, sketchy hand-drawn effect. 2 layers on top of each other. What do we do with that next? We take that level, level. We multiply it. Basically, we get rid of anything below 0.1. We clamp it to 0 to 1. Okay, so we can come back over here. So, yeah, so this is basically saying if level, right, edges first. So if level is less than 0.1, that's 0, and above 0.1, it's 1. And we're multiplying level by that, so essentially we're saying anything below 0.1 is going to be 0, and anything above is going to be whatever level was. So we're chopping off that lower bit, which I suppose is what clamp would have done in the first place. Yeah, I think so. I think that's a waste of... Gosh, anyway, I didn't always know what I was doing. Yeah, so that got rid of some of the sort of the floor for what we consider an edge. But I think it would have been the same to do this, personally. Just clamp at 0.1. Oh no, it's different. Oh, right, because it's changing the curve. When you multiply 0.5 by 0.5, for example, it becomes 0.25. And so this is actually making it more exaggerated. Whereas if we had like a straight line before, it's going to be a curve like this. Oops, not that. This. If we had a straight line, that's not a straight line, but you know what I mean. If we had a straight line before, it becomes a curve like this, a parabolic curve. So we get rid of some of the low values, and if, yeah, anyway. I don't feel like that changed it correctly, though. Oh, because I did this. Yeah, we still want zeros in there. Yeah, that's what I was doing. Okay. So we kind of got sketches going on. What else did we do with level? We figure out how much we want to draw. Yeah, so this is factoring in the draw. So coming back to here, if we undo this commented out bit, now we're doing our shading again, right? If we just do this, we'll end up with our shading like we had it before. Uh-oh. Ah, boogers. Let's just put this in for a second. I looked. Oh. We're not using that for anything, so let's turn it off. I hope you guys are kind of half following along with what I'm doing here. So again, it was a bunch of simple ideas tweaked to hell and then layered together. Okay, so I included an edge already. Did I force that? No, that was included. Okay, so in our sketch, we've already got edge included. In fact, the original was just solid edge. Let's put it back the original way for a second. I thought it was too intense, but there could have been a good reason for that now. So these are the straight edge we get right out of the photo, quote unquote photo of the screen, right? And so then this is figure out our rough sketch lines. So figure out the draw amount. We take the fractal we had. We got the radial float radial equals 1.0 for the moment because I'm not calculating the radial, but that was what had the lines fade out towards the edge of the screen. So we're doing a similar thing. We increase the draw amount or decrease it based on the edge, which means if we have no edge at all, our draw amount goes to 0. Oh, but we've already got a draw. I'm doing some weird stuff here. But yeah, so we take a curve on drawn. Drawn. What was drawn? Oh, we don't sample drawn. I think drawn. Yeah, I don't sample that one. But that's basically a higher resolution version of our sketch. Our hashed texture. So we sample that, but we sample it at a really high frequency, and that's our sort of darkest, you know, hash, that kind of hash. And so we make that a super curve. I think I showed you guys that. I don't have a spreadsheet loaded. But you can imagine if your linear curve got turned into a parabola, it's going to get even more corner looking by multiplying it again. So we're basically increasing the contrast between the lowest values and the highest values. And that's what we're mixing. That's what we're using as our black color. And we mix that with whatever shading we created up there by the draw amount, which is sort of you know, that fractals and blah blah blah. So let's see what this does. There's still a little bit of magic in here I haven't really explained. Okay, so we've got some little edges that come. It's subtle, right? But that's our hand-drawn shader, right? And so you get like these kind of close-up things that kind of look sketched. Let's go ahead and build the radial stuff in. we'll want to see towards the edge here. So let's look at what I was doing with radial. The radial I do some other things with the edge here. That I'm not doing in the other one. Right, because I was just pumping that in directly, and apparently... Oh, so this fades out yeah, so this fades out the edges, the edge itself, the edge factor. So let's move radial over first. I'll explain what radial's doing. The only place I use radial is down here, so this is where we'll calculate it. Calculate a fade for the sketch lines based on the distance from the center of the screen. So we're going to take the length of the middle of the screen minus the texture coordinate. We could have done texture coordinate minus middle of the screen. It wouldn't really have mattered. And we shorten that to be 170, you know, 3/4 of the distance. And we take the distance, we clamp it. So let's center distance equals, right, just so we can be a little more self-documenting. And then interesting, so we clamp that to 0. So basically the radial is only going to be half again. Then yeah, so 0 to 0.5, we invert it and multiply it by 2. And then we don't need this anymore. Let's see what that does. It's weird. I think I could have simplified that math. Yeah, so it lightened it around the edge. But this is weird. Why am I doing this? So length is going to be the distance from the center, and we've shortened it so we kind of brought it in from the edge. To make this seem like a shorter length than it would normally be. We clamp that from 0.5, so things close to the center of the screen, 0, they get larger. At some point we clamp it. It doesn't seem to be clamped. Okay, so we clamp at 0.5. So then it's 0 at the center and 0.5 out here, and 0.5 out here and 0.5 out here, because it stops. It's somewhere halfway along. Maybe we should just visualize these values. Yeah, let me see. Again, in shader debugging, sometimes it's just a good idea to see what your values are. So let's see what that radial is. And we can see what the, okay, so yeah, it's kind of smooth over the thing. Black in the corner, okay. What would have happened if we had only clamped 0 to, oops. What if we had only done 0 to 1. How would that have been different? Okay, so that's, okay, inverted. Right, 0 here, 1. We want to invert it, which is kind of what this is doing. But why wouldn't we have just done that? It's not a very nice curve, that's why. Okay, so we have a nice curve that I figured out a long time ago, which, you know, fades out nicely towards the corners. Oh wow, it's already after 11. And so then we mix that in with our sketch stuff, and we get that thing. Right. Oh yeah. So I've like wiped out the color. It's kind of cool looking though. So turn that back. So we should get back to what we had. Okay, and it kind of fades out towards the corners. The other thing was I had done some magic with this edge stuff. X edge. Yeah, I'm completely confused. I think I accidentally reused the word edge. For something different in my version of the shader. Right, because I had this edge level that I was just using for fun. And down here, so where was I using edge? Yeah. So I grab an edge here. And I used it, oh, just for looking around. And so this is a different edge. That's why. Okay. This is like edge of the screen. Let's call this one raw edge. I want to keep it around for debugging purposes for the moment. Or, so then let's call it debug edge, eh? Why not? Okay. And then so I added in X edge, Y edge. So, and this needs to be calculated before I use edge up here. So let's say calculate the screen edge fade factors. Okay, so what I'm doing again is taking the distance. Ooh, there we go. My cord was caught around my foot. Okay, so it's kind of the distance again. We're taking 0, so this will be minus 0.5 to 1. No, minus 0.5 to 0.5, we multiply by 2, so we get plus or minus 1 in the y direction, plus or minus 1 in the x direction. We then make a big curve out of that, make a big, or sharp curve out of that, multiply by 0.5, and then we invert it. So let's do our standard, let's look at it thing so you guys can visualize what edge is. I'll temporarily comment this stuff out. Okay, so let's refresh. Okay, so this is a different edge than our radial. What I'll do is I'll show you the two compared together, maybe. So let's make the regular radial be red, the edge will be green, and yeah, so we'll see. But I don't know if this will matter, because yeah, so I guess maybe it's not easy to see, but they vary at different rates. Towards the edge, the fact that it's green means that the edge value is brighter than the radial value. So that's cool, and all. That's cool and all, man. That's cool. And so then, yeah, we use that to kind of mute the color value that we got, which is sort of, yeah, our brightness and darkness. So this should be our kind of final sketch layer. Ooh, somebody's really dark. Something I did differently is unhappy. Thinking. I mean, it's not awful, but it looks more like charcoal, and like really in a bright desert, we should not have a dark sky up there. That to me indicates that the fractal value is too influential. And that could be true. Let's just take it out for a second. Okay, we still get some darkness in there. Did I screw up my fractal? Times 0.2, make it super small, add it to 0.8. Fractal value should be large. So why did we go from total, like pretty close to being right, to total crap all of a sudden? I think this was not the original. Yes, I already did that. I think I already did that. Color times edge. Yeah, I changed it when we when I multiplied by 0.5, it changed it. Okay, so let's do this. That might have fixed it. Ooh, yeah, there we go. We're back to normal. Yay! Alright, so that's pretty close. We get like this kind of shaded view. It's kind of neat. And as you get towards the edge of the screen, it gets turned more sketchy. Right, as the corners, see, kind of fades out. And you can see the, if you look at the spirit temple there down in the lower quarter, you can see kind of the sketchy lines change as we look around. They're probably offset a little too much. From, we get this weird kind of highlight effect that looks more like embossing. So I suspect that there's an offset we need to include even in the, let me make sure I'm porting all this correctly. So I avoided some UVs early on that I may need to bring over now. All of that is fine. All of that is fine. I don't think we ever use this Z value, but we could have. Yeah, we don't ever use that Z value, so we could avoid doing the texture lookup. Yeah, I thought it would be good for reinforcing. I think I originally thought it'd be good for reinforcing edges. Yeah, in fact, I did in part of the coloring originally include that. Just gonna see if there's anything I'm missing here. For one thing, I used to use a different color value. I would just use whatever max of RGB was instead of the. So we could try changing how we're getting the level just to see if it changes. All of my original values were based on all my original tweaking were based on that incorrect, in my opinion, today. This right here. So let's set color level to screen color, the max of screen color R, screen color. So that is what the old code would have done. Which doesn't look to have changed anything. Or maybe it just took a second to update. I can't tell, to be honest. So let's take a screenshot. So this is the original, like the original, not my current original. Okay. Let's do it again. Something is bound to be different, right? But nothing changed, I think. So let's do another screenshot. And so then we'll start, mouse set, scripter. Yeah, there's no difference between those, so I'm either screwing up or it's not really recompiling. let me real quickly make sure. I should probably wrap it up here in a minute. Let's just make sure this is doing anything at all. It is. Okay, that's good to know. Yeah, so I guess the effect is so subtle in this particular image that it doesn't really matter. I kind of did want to try one more scene. If you guys are willing to hang out for a second. Yeah, that's what I was just going to suggest. I think I'm going to do that real quick. Let's capture a different scene real quick. I mean, I got all 2 weeks left to play with this stuff, so do a little bit more tonight. Bum, 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 bum. Hello, Mythruna music. Let me see what marks I have in this world. It would be good to find a town. I think a town would be a decent example. Nice. I mean, there's always the chance, right? I would be affected by that too. But I'll be on vacation for 2 weeks. Okay, so let's first of all change the time to something like that. What marks did I have? Ooh, I got no marks. This is a desert world. So let's mark Moongate so I can come back here. Then we will respawn. I mean, up here at the spawn tower could be a pretty decent. I'm gonna fall down if I'm not careful. That's a pretty view right there, looking out across the desert. Alright, so do we get any decent views down here? Whoa. Let's make it a little brighter. Okay. Can we get a view of the tower? I guess it doesn't really matter because whatever I capture, I'll be able to move around a little bit. Yeah, so the thing is, like, the far horizon stuff is so faded out. Okay, so I think this will be a decent place to capture for now. Dump scene, or scene dump. Boink. There we go. And do I exit out? I hear the birdies on the game. Okay, so then exports, we want that one. We'll copy it to model set scripter, drawn, models, spawn.j30. Alright, let's go in here, change the scene from that to spawn, and then run it. I haven't tried anything with... I've only tried the desert so far, so hopefully this will load. Yeah, okay. We are actually below the ground, which is why we, where's the spawn tower? What we could do, in fact, is just lower. So this was the move we needed for this. We're going to need a different one. Let's try 255. And we're still not, okay, yeah, because okay, we are in a treat. Holy crap. Oh, that's kind of cool. Alright, so that is the view of the far terrain. Here's the view of the spawn tower. I think this is okay. Like, I think that's a decent sketch effect, right? And you can imagine bringing back a little bit of the color. Let's try that. There will be dwarven areas and things, dwarven cities that are underground. Without getting too much into it, yeah, it does look way better than the desert. But yeah, that's really cool looking. I wonder if I could just bring a little bit of color back in. Oh, well, one of the things is we're still using white backgrounds, so let's use the real background. Am I sampling the background? Where? I am not even sampling the background. Let us copy that real quick. So I'm not even using the proper background. So let's make it look like a real sketch, because it'll be on paper, which ironically is the sand texture. So then I come down here, and where I'm mixing this, right, I instead, oops, mix the background, and so that will be paper. Yeah, so now it looks like it's on paper, right? It got a little bit of sepia tone too. I think the desert will look better on here too. Okay. Uh-oh. You guys probably just hung. Let's see. Okay, seems to have come back. Okay, so we could technically mix in a little color into the shading. Maybe based on distance even? Okay, wait. I'm gonna ahead of myself. Where did we get the shading? There we go. No. Yes. Because then we put the rough sketch lines on top of that. So technically, we could mix in just a little of the original color, but like just a teeny bit. Yeah, just a little shading. Let's try a little bit more. But I'm just thinking of eventually I'm going to give the players the ability to kind of sketch in these layers, and they might be able to, you know, then draw over them. And so might be fun to have a magic coloring. Yeah, so look, we get a little bit of color in, right? I kind of like the black and white version better for now, but it looks cool with a little color as well. Anyway, this is so let's put the time factor back in, which makes it look bonkers, but at least every screenshot would be a little different, right? So if we put G time, but you'll see why I don't like to leave this running, because it's kind of intense, right? It really shows off how the fractals work, though. But it's just a little weird, right? But so we come around here. We've got a nice little sketch of our opening thing. But that's why I don't like to leave it on. It kind of shows too much of the magic when we're just editing it. If you're taking single screenshots, you want every screenshot to look a little different, right? But it shows too much of the magic when you're doing it. Yeah, so you get this, and as we walk through, we get like sketches of the insides. I kind of wanted to find a town because I felt like I could do a pretty decent close-up map with the sketch layer. Let's take out the color again. With, you know, as you're walking around the town, I could do almost a different viewport view where there was no perspective, right? So you just get the straight top-down view, isometric view of the buildings, and I could make a pretty decent, you know, hand-drawn map close-up. Basically, if you zoomed in further on your map, you would get kind of this sketched view. Anyway, I think it looks pretty cool. And this one's going to be pretty easy to integrate into the game. But yeah, so we have a hand-drawn shader. Drunk drug vision you get. Yeah. Oh yeah, there'll be poison, all kinds of stuff. But yeah, it would be fun to have a drunk effect. It's just got the wavy, or a drugged effect, right? Yeah, I like it. It's looks pretty good. Past me did a decent job with this. Oh yeah, the desert actually looks pretty cool from here, right, where you get the contrast of the... Yeah, I like it. I'd be able to create a bunch of new screenshots for splash screens this way. Like if you could imagine Fade, you know, Mythruna girl standing there looking out at us. That would be... yeah, so like... Imagine an NPC standing here, you know, get a view like this, or even, oh yeah. So this is the one, right? This is the money shot. Have like an NPC standing there, and you can like use this as a splash screen. So yeah, it's good times. This is fun. I like it when we can get something done in a night, right? Yeah, we've been overheating my CPU a little bit here, but cool. I'm glad that works. Alright, thanks guys. Let me close out the stream. If you have any other ideas or other comments, you know, please like, comment, subscribe. If you were new to the channel and happen to hang out, that's cool too. Please subscribe. You can also, there was the link in the upper left of the corner where you could download the game. That's also where you can join the Discord. And I will see you guys next week. I have no idea what I'm going to do for next Friday. It'll just depend on what kind of cool stuff I get done this week. Maybe I can cut a release on Monday. We'll see. All right. Thanks, everybody. I will see you online.